Okay, let's solve a few more free fall problems. We'll go a little quicker this time. A brick is dropped from a height of 10 meters. What is its speed on impact? I want you to first of all see that this is a free fall problem. The word drop tells us that. We have a height. Let's talk about what to do with this. Remember, free fall. Immediately just write down ATVVD. We know that it's acceleration, and these are the 5 acceleration variables. Now we'll go down the list. Remember, you don't have only one thing. There are 2 other things that you'll be expected to know, and that's the acceleration and the VI. So we know that A is negative 9.8, always with a free fall. Time, we don't know. They don't give it to us. Initial speed, we know is 0 because the brick is dropped on the way down. The VI is 0. The speed at the top is always 0, whether it's VI or VF. VF, we don't know in this case. They do not tell us. It's going to be something other than 0, obviously. And then the D, the height from which it falls, this distance right here is 10. Now again, be really careful. And sometimes I'll say this in class. I'll say, what's the distance? And people say 10. And I'll say, are you sure? Are you positive? Hint, hint, that's a joke. No, you're not positive. You're negative. Why is it negative? Because this is a negative direction. It's falling downward. And so this is technically a vector called displacement. Sometimes we've called it distance, and it's not exactly correct. We have to think about direction when we think about this one. On the way down, the direction is negative, so this has to go in as a negative. The unknown here, what is this problem asking for? What is its speed upon impact? That's definitely not time. It's this one right here. So in this problem, I want to know VF, but I don't care about T. So let's find an equation that has VF, but that does not have T. So check it out. You look at it, see if you can find which one it is. The only one that doesn't have T is this guy right here, number 6. We got VF, we don't have T. VF squared equals VI squared plus 2AD. Let's write it down. VF squared equals VI squared plus 2AD. Now we're going to substitute numbers and solve. VF is what we're trying to find. I'm going to leave it exactly the way it is. And the squared is part of the equation. That has to stay there too. VI is 0. Plug it in. 2 is part of the equation. Leave it there. A is negative 9.8. And D is negative 10. Now we can do some simplifying. 0 squared is 0. 0 times 0 is 0. And as I said before, 0 doesn't change anything. So that can go away. That's going to go away. So now we have this left. 2 times negative 9.8 times 10. Again, let's think about the signs. We have a negative times a negative. I know that's going to be a positive. So I know that all of this is going to end up being positive. I'm not even going to put these negatives in the calculator. That's what I prefer to do. So 2 times 9.8 times 10 is what we have there. We can do that all at the same time, and we get 196. So to rewrite this, I now have VF squared equals 196. I don't want VF squared, I want VF. To get rid of the squared, we will take the square root and do the same thing on both sides. Square root of 196 is what I need to do now. And the square root of 196 is exactly 14. So the VF we found is 14 meters per second. This brick is moving at a speed of 14 meters per second at the very instant it impacts the ground. Let's check out another one. We got Sherman right here on number 10. He dropped a penny from the top of a tall building. Don't recommend doing that. Not as big of a deal if there's air resistance, but we are neglecting air resistance in this because we're only looking at free fall. Penny hit the ground 4 seconds later. How tall is the building? Again, we know that it's a free fall problem. I'm going to write down ATVVD and start moving with my variables. I know with a free fall problem that A is going to be negative 9.8, even though they don't give it to me. Time, they gave us the time. It was 4 seconds. the VI, the penny's dropped, so the VI at the top is 0. Speed at the top is 0. VF, don't know that. Remember, that's the speed right before the penny hits the ground. We don't know. They don't tell us. And the D, the displacement, really is the question they're asking. How tall is the building? Another way we could say that is, how far did the penny fall? That's the height of the building. That's the question that they're asking. That's my unknown. That's the one that I care about. Therefore, this other unknown, VF, I don't care about. I can move forward because I know 1, 2, 3 of the 5 of these. I care about D, don't care about VF. Now we're going to find an equation that has D and not VF. Look for it, and it is equation number 5. We've used this one before. Now we're going to solve for something different. D equals VIT plus 1/2 AT squared. Write it down. And then substitute numbers and solve. D is what we're looking for. Leave it the way it is. VI is 0. T is 4. 1/2 is part of the equation. Leave that the way it is. A is negative 9.8. And then T, again, 4. Don't forget that squared right there. It has to stay there. Now we need to do some simplification in order to solve this. Let's simplify the problem. 0 times 4 is not 4. It's not 1. It's just 0. 0 times anything is 0. That goes away. So this, you can start to see this little term a lot of times is going to be taken out on a free fall problem because it's going to be 0 anyway. We'll have that happen a lot. Now we just have this to contend with. So remember from before, half of 9.8 was negative 4.9, right? So just for ease sake, I can go ahead and write that in there. So I now have negative 4.9 times, we know that, now this squared only applies to this number, not to the rest of this stuff. Squared only applies to 4. I know that 4 squared is 16. So now I need to do 4.9 times 16. I don't know that in my head, off the top of my head. 78.4 is what we get here. Now, it's negative. We have a negative right here. Negative times a positive is going to be negative. Again, I didn't put it into the calculator, but I can look at it and tell it's going to be negative. But then it's really important to look at this and go, is it okay that I got a negative? Yes, it is, because what direction was the penny falling? Downward. It had a negative displacement, so that D that we found should be negative 78.4. Let's look at just a couple others real quick, and these are different because these are launched upward, straight upward instead of down. So remember, on the way up, let's just do it down here. On the way up, remember the V at the top is 0, but on the way up, that's our VF. That's the final speed, the one at the end. The VI at the bottom is something other than 0, and they'll probably give us that speed. So let's remember that as we solve these problems, but they are still free fall problems. It's still a free fall because it doesn't matter whether the object is going up or whether it's coming down. It's still only the force of gravity that's acting on that object, pulling it downward. That's why the object on the way up slows down and the object on the way down speeds up because of the same force and the same acceleration. So they're both in free fall. This is still a free fall problem, even though we throw it up in the air. It isn't falling down, it's falling up. And I know that sounds kind of strange, but that is true because it's undergoing the same acceleration for the same reason. So it is a free fall problem. So we'll do our ATVVD. A is negative 9.8. Some people get confused about this one because they go, wait, it's going up. Why is the A negative? The A is always negative 9.8 because that A has nothing to do with the direction of it. It has everything to do with the direction of the force of gravity, which always pulls down. So this acceleration due to gravity is always negative 9.8 for a free fall, regardless of the direction of motion. Time, don't know. Initial speed. It's this. Remember, this speed is the speed that it leaves the ground at. V equals 25 right here. That's my VI, 25 meters per second. What's the VF? The speed at the top is the VF, and it is 0. The speed at the top is always 0. D, don't know. Matter of fact, that's what they're asking us for. How high will it go? High is another word for a distance or displacement measurement. That's what we're looking for. So since that's the variable I care about, I don't care about t in this case. Let's find an equation that has d but not t. So let's look for that. Which one has t and not, sorry, d as in dog, but not time, and it's number 6. VF squared equals VI squared plus 2AD. So we plug numbers in. VF is 0. That one's going to turn out real easy, isn't it? VI, 25. Don't forget the squared. Plus 2. A is negative 9.8. D, don't know. That's what we're solving for. Now we can simplify. 0 squared on the left side is 0. But it's got to stay there. We have to, now we got rid of the 0. Check this out. We were able to get rid of the 0 in problems like this because there were other placeholders on this side. It's just that 0 plus something doesn't change anything. Now it's the only thing on the left side of the equation. I can't just get rid of it. I can't have nothing on the left side of the equation. There is a 0. So 0 equals 25 squared, in case you forgot, is 625. 625 is 25 squared. Plus, now we have this to contend with, 2 times negative 9.8. This isn't half of 9.8. It's not 4.9 anymore. It's 2 times negative 9.8. This one's relatively common as well. But again, I'm not going to enter the negative because I know it's going to be negative. I have a negative times positive. 2 times 9.8 is 19.6. So that's actually negative 19.6. And I'm going to bring that D down. Now we have some algebra to do. We're going to do the add and subtract first. So this one is not an add-subtract operation, but this one is. 625 is added, so we're going to subtract it first. So now I have negative 625 equals, bring all this down, negative 19.6 D. Now to get rid of the 19.6, I will divide. Divide by negative 19.6. So now I have this operation to put in my calculator. Negative divided by a negative is going to be a positive. I'm not going to put those in. 625 divided by 19.6 is 31 point, I'm going to call that 31.9. The 8 makes the 8 a 9. So my D here is a positive 31.9 meters. Is it okay that we got a positive? Yes, it is, because this is a positive displacement. This rocket is moving upward. It will go 31.9 meters into the air before it stops. All right, the last one here about the cannonball, I'm actually going to let you do this one on your own. It's relatively simple, except that you're looking for something different. How long will it take the cannonball to reach its peak height? You're looking for time there. It's shot from the ground straight upward at a speed of 150 meters per second. This you should get 15.3. How long will it be until the cannon falls back down to the ground? So this is to reach its peak height, right? And then once it does that, it's going to start to, what goes up must come down, right? How long is it going to be in the air for total? So the trip up and the trip down, you should get 30.6 seconds for this. So see if you can do that on your own. If you have questions, let me know.